You're standing on a beach that used to be a coastline. Now it's just ash. Gray ash, as far as you can see, in every direction. The sky above you hasn't been blue in months. It's a strange dull orange, like the sun is bleeding through a curtain. You count the people around you. Maybe 20 on a good day. That's it. That's the entire population of your world, as far as you know. Somewhere out there, other groups might be alive. Or they might not be. And the question that's keeping you up at night isn't about food, or fire, or shelter. It's simpler than that, and somehow worse. Is 20 people enough to keep humanity from disappearing forever? That scenario isn't fiction. Scientists believe something close to it actually happened. And it forces us to ask a question most people have never thought about. What is the actual bare minimum number of humans needed to bring an entire species back from the edge? Not thousands. Not even hundreds. We're talking about the smallest number that could still work. And the answer is going to mess with how you think about survival, family, and what it really means to be enough. Let's rewind. About 74,000 years ago, a volcano called Toba, on the island of Sumatra, erupted with a force almost impossible to imagine. It didn't just destroy the region around it. It threw so much ash and sulfur into the atmosphere that it may have triggered a volcanic winter that lasted years. Sunlight dimmed. Temperatures dropped. Plants died in mass extinctions across continents. And some scientists believe the global human population dropped to somewhere between 1,000 and 10,000 breeding individuals. Not 10,000 villages. 10,000 people scattered, isolated, barely holding on. Think about that for a second. Right now, more people live on a single city block in Mumbai or Lagos than may have existed on the entire planet after Toba. The species that would go on to build pyramids, write symphonies, and land machines on the moon may have passed through a bottleneck so narrow that a bad flu season could have ended it. That's not a comforting thought. But it's the thought that sets up everything else in this video. Here's the question we actually need to answer, though. Forget the historical debate for a second. Scientists still argue about how severe the Toba bottleneck really was. The real question is a math and biology problem. If you had to rebuild a healthy, sustainable human population completely from scratch, starting today on an empty world, what's the smallest number of people you could start with and still succeed? Not just survive for one generation. Succeed. As in, still have functioning, mentally and physically healthy humans 500 years later. You'd think the answer would be small. A man and a woman, right? Two people like the opening chapter of a religious text. But here's what scientists actually found when they ran the numbers. Two people isn't just insufficient. It's a death sentence for the species, just a slower one than starving to death. To understand why, you need to understand something most people never think about. Your genes are basically a giant insurance policy, built over millions of years, and diversity is the premium that keeps the policy valid. Every human carries around 20,000 genes, and within those genes, small variations, called alleles, determine everything from your immune system strength to your risk of genetic disease. When a population is large and diverse, harmful mutations get diluted. They hide behind healthy versions of the same gene, inherited from a different parent, a different lineage. But when a population shrinks, when the gene pool becomes a gene puddle, those harmful mutations start finding each other. Relatives start breeding with relatives, whether by choice or by simple lack of options. And a phenomenon called inbreeding depression begins to set in. Inbreeding depression isn't a metaphor. It's a measurable biological collapse. Offspring become smaller. Immune systems weaken. Fertility drops. Birth defects rise. In severely inbred animal populations, scientists have documented drops in litter survival rates by over 50% within just a few generations. Humans are not exempt from this rule. We are, biologically speaking, just another mammal playing by the same genetic rules as every other species on Earth. So if two people can't do it, how many can? This is where the science gets genuinely fascinating, and where you need to sit with the number, because it's not what you'd expect. Population geneticists use a concept called the minimum viable population, or MVP. It's the smallest group size that gives a species a reasonably high chance, usually defined as 90 to 95%, of surviving for hundreds of years without going extinct from genetic problems, random disasters, or simple bad luck. For most large mammals, researchers have found this number tends to sit somewhere between 4,000 and 5,000 individuals. Not couples. Individuals. That number accounts for genetic diversity, random deaths, disease outbreaks, and the fact that not everyone in a population successfully reproduces. For 1,000 people. Let that sink in for a moment. Not to build a civilization. Not to invent writing or agriculture. Just to keep the human species from quietly fading into extinction over a few centuries. But here's what scientists actually found when they dug even deeper. The 4,000 number is a general mammalian estimate, and humans, because of our unique biology and behavior, might need fewer. Or, depending on the conditions, might need more. This is where things split into two very different survival stories, and both of them are stranger than fiction. Let's start with the smaller, more hopeful story, the story of Pitcairn Island. In 1790, a group of mutineers from the British ship HMS Bounty, along with a handful of Tahitian men and women, settled on a tiny, remote island in the Pacific called Pitcairn. 9 British sailors, about 18 Polynesian men and women, a total founding population smaller than a modern elementary school classroom. For decades, this tiny population was completely isolated, hundreds of miles from any other human settlement, with no ships, no contact, no rescue. You'd expect this population to have collapsed under inbreeding within 2 or 3 generations. And in some ways, it nearly did. Early Pitcairn history includes violence, disease, and desperately small gene pools. But the population survived. It grew. Today, descendants of those original mutineers still live on Pitcairn and in nearby communities, carrying DNA traceable directly back to that founding group of under 30 people. So does that mean 30 people is actually enough? Not exactly, and this is the part that should genuinely unsettle you. Pitcairn survived because of specific, almost lucky conditions. The founding population had a reasonably even mix of men and women. They had access to fresh water and land for food. And crucially, later on, occasional contact with outside ships introduced small amounts of new genetic material into the population, even if indirectly through emigration and immigration over time. Pitcairn wasn't a closed genetic system forever. It had leaks, and those leaks may have saved it. Compare that to a much darker case. Tristan da Cunha, one of the most remote inhabited islands on Earth, located in the middle of the South Atlantic Ocean. Its founding population was even smaller than Pitcairn's, around 15 settlers in the early 1800s. And unlike Pitcairn, Tristan da Cunha remained almost completely isolated for generations, with far less genetic mixing from outside contact. The result was one of the most well-documented cases of a founder effect in modern human history. A significant portion of the island's population today carries a genetic predisposition to asthma and retinitis pigmentosa, a condition that causes progressive blindness, both traced directly back to a handful of founding individuals. When your entire gene pool comes from 15 people, whatever genetic quirks those 15 people happen to carry, good or bad, become massively amplified in every generation that follows. This is the founder effect, and it's one of the most important concepts in this entire topic. It's not just about how many people you start with. It's about which specific people and what hidden genetic baggage they happen to be carrying, because in a small enough population, there's nowhere for bad genes to hide. Now here's where we need to reset everything you think you know, because what you're about to hear was largely left out of mainstream discussions of this topic for decades. Researchers modeling human extinction risk have found that raw population numbers only tell part of the story. The real determining factor isn't just how many people, but something called effective population size, a number that accounts for age, sex ratio, and reproductive access. In a founding population of 100 people, if only 20 are of reproductive age, and only 12 of those actually go on to have surviving children, your effective population size might functionally be closer to 12. The other 88 people matter for labor, protection, and knowledge, but genetically, they contribute almost nothing to the future gene pool. This is why some researchers now argue that the true minimum viable population for long-term human survival, factoring in realistic reproduction rates, disease, accidents, and social breakdown, might need to be closer to several hundred to a couple thousand people at minimum, even though a technically smaller group could survive short-term through pure luck like Pitcairn did. And this connects to something deeply human, something you've probably felt yourself without realizing it. Humans have an evolved, almost instinctive discomfort with small, closed social groups. Ever notice how uncomfortable extremely tight-knit, isolated communities can feel from the outside? Cults, remote family compounds, isolated religious sections. Part of that unease might be more than cultural. It might be a deep evolutionary alarm bell, a leftover survival instinct warning you that small, closed gene pools are dangerous, both socially and biologically. Our ancestors who avoided marrying too close to home, who sought partners from neighboring bands, who valued outsiders joining the tribe, were quite literally protecting the species' genetic future. You carry that instinct in your bones today, even if you've never once thought about population genetics. That's the first connection to modern psychology. Here's the second, and it's about something you do every single day without noticing. Humans have a strong, cross-cultural incest aversion, and for decades, scientists debated where it came from. Was it purely cultural? Purely moral? But research into something called the Westermarck effect found a startling biological pattern. Children raised in close proximity from a very young age, even if genetically unrelated, like unrelated children raised together on the same kibbutz in Israel, develop a strong sexual aversion to each other later in life, almost identical to the aversion between biological siblings. Your brain doesn't need a DNA test to protect the gene pool. It uses a simpler rule. If we grew up together like family, treat each other like family. This instinct, embedded so deep you've never consciously questioned it, exists because ancient small populations that failed to avoid inbreeding paid the price in weakened, sick, or infertile offspring. The aversion you feel isn't random. It's a survival mechanism forged by exactly the genetic math we've been talking about this entire video. So where does this leave our original question? If 2 people is a death sentence, and even 30 to 50 is genetically fragile and risky, what's the actual number where scientists say humanity would have a real, solid chance? This is the part of the video where we need to talk about something that sounds like science fiction but is actually a real area of serious research. What it would take to repopulate Earth after a total civilizational collapse, or even what it would take to establish a self-sustaining human colony on Mars. NASA-funded researchers and independent population geneticists have modeled exactly this scenario for space colonization proposals. Their answer, using long-term genetic sustainability models, consistently lands in a range far higher than most people would guess. To maintain a genetically healthy population over multiple centuries, without needing outside genetic contact, researchers generally estimate you'd need a founding population of at least 160 people, and some models push that number as high as several thousand, depending on how strictly you want to avoid inbreeding depression and how much genetic drift you're willing to tolerate over generations. One widely cited study modeling a multi-generational voyage to a nearby star system calculated that a minimum of 98 carefully selected individuals could theoretically sustain a healthy population over 200 years, but only under nearly perfect conditions. Careful genetic pairing, no random chance breeding, controlled family sizes. Essentially, a managed breeding program with almost no room for human error, emotion, or free choice. And that's where the story gets uncomfortable, because real human populations don't work that way. People fall in love with the wrong partners, genetically speaking. People refuse to have children with people chosen for them. Disease wipes out specific families unevenly. Accidents kill fertile adults before they reproduce. Real-world chaos erodes the clean math almost instantly, which is why most serious researchers now argue that for humans specifically, factoring in realistic behavior and bad luck, you'd want a starting population closer to at least 500, and ideally several thousand, to have real confidence in long-term survival. Now here's the moment we need to slow down for, because this is the piece of the story that tends to get left out of documentaries entirely, and it might be the most important part. Population numbers only solve the biological problem. They don't solve the second, quieter problem, the one that doesn't show up on a genetics chart, but might actually be more dangerous. Psychological and social collapse in extremely small, isolated groups. Anthropologists studying small, long-isolated human populations, from remote Arctic communities to shipwreck survivor groups to real historical isolation events, have documented a consistent, disturbing pattern. Below a certain group size, human social structures start to break down in specific, predictable ways. Roles become rigid and inescapable. Conflict has nowhere to dissipate, because there's no larger community to absorb it or offer new relationships. Leadership disputes turn existential, because there's no larger tribe to defect to. In several documented historical cases of small isolated groups, shipwreck survivors, remote expedition teams stranded for extended periods, researchers found that group cohesion frequently mattered more than food supply in determining who actually survived. Groups that fractured into infighting factions saw dramatically higher death rates than groups of similar size and resources that maintained cooperation, even under identical harsh conditions. This connects to the third and final piece of modern psychology we need to talk about. Have you ever wondered why humans feel almost instinctively suffocated by extremely small, permanent social circles? Why long-term isolation with the same handful of people, even people you love, can wear on the human mind in ways that seem to defy logic? Long-duration isolation studies, conducted by space agencies preparing for Mars missions, have found that even highly trained, psychologically screened adults begin to show serious signs of social fatigue, irritability, and cognitive strain after extended periods in extremely small, closed groups, often within months, not years. Your brain seems to be built with an assumption baked deep into it. Humans are supposed to exist inside larger networks. Not couples. Not single families. Networks. Somewhere in your evolutionary programming is an ancient expectation of tribe size, and small permanent isolation quietly violates it, even when your physical needs are being met. So the honest, science-backed answer to what's the bare minimum isn't really one number. It's a combination of numbers, layered on top of each other like a survival checklist. Biologically, to avoid immediate genetic collapse within a generation or two, you'd need at minimum several dozen genetically diverse, unrelated individuals. Pitcairn's example shows this is technically survivable but fragile and lucky. To have real long-term genetic sustainability across centuries, without outside contact, most serious models say you need somewhere between several hundred and several thousand people. And to maintain psychological and social stability, the invisible variable that determines whether people cooperate long enough to reproduce successfully at all, most anthropological research suggests you need a group large enough to contain multiple overlapping social units. Not just enough people to make babies. Enough people to make a society stable enough that making babies remains possible generation after generation. Now for the part of this story that's genuinely disturbing, the reveal we've been building toward, the one that connects directly back to where we started, at that gray ash beach after Toba. If the Toba bottleneck theory is accurate, and if human survival really did shrink to somewhere between 1,000 and 10,000 breeding individuals worldwide, then modern humanity, all 8 billion of US, may be descended from a population that was, at points, dangerously close to genetically insufficient by the very standards we've just laid out. Some researchers who study human genetic diversity have noted something striking. Compared to other great ape species, humans have remarkably low genetic diversity for our population size. Chimpanzee populations, even smaller ones confined to isolated regions of Africa, often show more genetic variation between individuals than humans do across the entire species, spread over every continent on Earth. That's not supposed to make sense. A species of 8 billion should be wildly diverse. But the math suggests something did happen at some point in our deep past that thinned the gene pool dramatically, and every single person alive today is a descendant of whoever made it through that thinning. Sit with that for a second. Every argument you've ever had, every person you've ever loved, every stranger who's ever cut you off in traffic, all of you, tracing back through an unbroken chain of survival, to a genetic bottleneck so narrow that some researchers describe it as the closest our species has ever come to disappearing entirely. You are not just the descendant of survivors. You are the descendant of an almost extinction event, repeated who knows how many times, across tens of thousands of years, each time narrowly avoided by numbers that, according to the science we've just walked through, should barely have been enough. And that's the thought worth carrying with you after this video ends. We build our modern lives around individual choices, who we date, how many kids we have, whether we move away from family, whether we ever meet anyone outside our small circle of friends. It feels personal. It feels disconnected from anything as abstract as population genetics. But every one of those choices echoes an ancient, invisible math problem our ancestors were solving without even knowing it, generation after generation, on the very edge of extinction. The instinct that pulls you toward new people, new places, new connections beyond your closest circle. That isn't random. It might be the same ancient survival code that kept this entire species alive, running quietly in the background of your life, right now without you ever noticing it was there.